Hello students, my name is Harish and today I'm going to explain you the topic making order out of chaos, early attempts at the classification of elements. This topic is from the chapter periodic classification of elements. So let's start. We all know that the matter around us is present in the form of elements, compound and mixtures, and the elements contains atoms, and all the atoms are of only one type. So that explains the first point here, that all elements contain atoms of only one type. At present, 118 elements are known to us. All these have different properties. Out of these 18, only 94 are naturally occurring, and the others are man-made. Now, as different elements were being discovered, scientists gathered more and more information about the properties of these elements. Now, the problem was that they were not able to organize them. We all like to organize things, right? So they found it difficult to organize. So they started looking for some pattern in the properties on basis of which they could study such a large number of elements with ease. Now, we all know that various things or living beings can be classified on the basis of their properties. For example, in a shop, you will always notice that the soaps are kept together at one place while the biscuits are kept together elsewhere. Even among soaps, bathing soaps are stacked separately from the washing soaps. And another example of this is you can notice at your home in the kitchen. Your mom will always place the spoons at one place and the glasses at another place, the plates at another place. Similarly, scientists made several attempts to classify elements according to their properties and obtain an orderly arrangement out of chaos. The first one to do so was Mr. Dobranier. In the year 1817, Johann Wolfgang Dobranier, a German chemist, tried to arrange the elements with similar properties into groups. He identified some groups having 3 elements each, so he decided to call these groups as triads. That's why they are known as Dobranious Triads. Now, what exactly did he do? Let me explain it to you. Dobranius showed that when the 3 elements in a triad means a group of 3. So basically, when the 3 elements were written in the order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other 2 elements. I know that it must be difficult to understand. You will understand it soon. Just wait. Now let's understand this better with this table. What exactly Dobranian is trying to say to us is that if you arrange the 3 elements, lithium, sodium, and potassium, according to the increasing atomic masses, you will notice that the atomic weight of sodium is the average of the sum of the atomic mass also of lithium and potassium. Exactly. So basically, if you add the lithium and potassium mass and divided it by 2, you will get the atomic mass of sodium. This is same the example with other elements. For example, here, chlorine, bromine, and iodine. If you add the atomic mass of chlorine and also the iodine and divide it by 2, you will get the equivalent something equal to atomic mass of bromine. So this is what Dobranier was trying to say us. Let's read the sentence once more and try to understand this. Dobranier showed that the 3 elements in a triad were written in the order of increasing atomic masses. The atomic mass of the middle element was roughly the average of the atomic mass of other 2 elements. I think it must be clear to you that if you add these 2 atomic mass and divide by 2, you'll get the atomic mass of sodium. But this method was not useful. Do you know why? That Dobranier could identify only 3 triads from the elements known at that time. Hence, the system of classification into triads was not found to be useful. So, another scientist stood up to help the community. His name was John Newland. In the year 1864, this British chemist attempted to arrange the 56 elements known at that time. Okay, he arranged them in an ascending order based on their atomic masses and observed that every eighth element had similar properties. On the basis of this observation, Newland's law of octaves was formulated. It was so difficult to understand. Let me explain it to you once again. So basically, he arranged all the known elements at that time according to their atomic masses, from the lowest to highest. Okay, and he noticed that every eighth element had similar property to the first element. Okay, that is what the next point says. The law of octaves states that every eighth element has similar properties, and the elements are arranged in the increasing order of the atomic masses. You will understand this better with the help of a table. Here, this this has been arranged according to increasing atomic masses, and you can notice that this element lithium has equivalent properties to sodium, and like you can notice that sodium is the eighth element for lithium. Same thing goes for beryllium and magnesium, boron, aluminium, carbon, silicon, and so on. To understand this, that these colored elements have same properties. The same colored elements have same properties. Now you must be wondering, why did this scientist name them as octaves? He actually connected this to music. You must all be familiar with the 8 octaves of music. Sa, re, ga, ma, pa, da, ni, sa. So basically he tried to arrange the elements according to them. See, for Sa, he wrote HF, means hydrogen, fluorine, chloride, cobalt, nickel, chromium. Same way. Here, 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 and also here. So this is what Newland tried to say. Let us read the sentence again and try to understand this. The law of octaves states that every eighth element has similar properties, and the elements are arranged in increasing order of atomic masses. Basically, you will take all the elements known to you will arrange them in an increasing order, and you will notice that every eighth element has similar properties. Okay, so lithium has same property to sodium, beryllium has similar property to magnesium, boron with aluminium, so and so on. But even though his attempt was very interesting, there were still limitations to his attempt. Let us study about that. It was found that the law of octaves was applicable only up to calcium. So, after calcium, every eighth element did not possess properties similar to that of the first. See, this I think is a very major flaw. It was assumed by Newland that only 56 elements existed in nature, and no more elements would be discovered in the future. But we know that in today's date there are 118 elements. Now, let us understand the next point. In order to fit the elements into his table, Newland adjusted 2 elements in the same slot, but also put some unlike elements under the same node. Basically, if you see at this table, he has given same position to 2 elements. He has given same position to cobalt as well as nickel. He has given the same position 2 elements here as well. And also, let us understand the next line which he said. Next line he said was he also put some unlike elements under the same node. Let's understand that. Note that cobalt and nickel are in the same slot. As I showed you before, cobalt and nickel are same slot. And these are placed in the same column as fluorine, chlorine, and bromine, which have very different properties than these elements. If you notice here, this fluorine, chlorine, and bromine are known as halogens. And these cobalt and nickel have very different properties than fluorine, chlorine, and bromine. So this was another major flaw in his table. And iron, which resembles cobalt and nickel in properties, has been placed far away from the elements. For example, where is iron? Can you find iron? Yeah, it's here. So iron has been placed very much far from cobalt and nickel, even though these three possess same or similar properties. This was another major limitation in Newland's law of octaves. And with the discovery of noble gases, the law of octave became irrelevant. Thus, we can see that Newland's law of octaves worked well with lighter elements only. So, thank you guys here